all. In this video session, we'll understand the concept of MapReduce. MapReduce works on the principle of divide and conquer. The data is split into independent blocks and processing is done in parallel by the mapper. MapReduce can work on commodity hardware and can solve large computational problems. MapReduce Job consists of two main tasks, map and reduce. MapReduce program executes in three stages, namely map stage, shuffle stage and reduce stage. The map or mapper's job is to process the input data. It takes input in the form of key-value pairs. The input file is passed to the mapper function line by line. The mapper processes the data and creates the output also as key-value pairs. Shuffle stage takes output of mapper, that means it takes key-value pairs generated by the mapper and shuffles them to combine the values having same keys. In reduce stage, each key will go to only one reducer. The reducer's job is to process the data that comes from the shuffle stage. After processing, it produces a new set of output which will be stored in the HDFS. The complete execution of map and reduce tasks is controlled by two entities called job tracker and task tracker. For every MapReduce job executed in Hadoop, job tracker resides on name node and multiple task trackers reside on data node. Job tracker acts like a master. Job tracker takes care of starting the mappers and reducers and assigning to the task trackers. Job tracker creates one map task for each data split and a set of reducer tasks. Job tracker is responsible for complete execution of submitted jobs. Task trackers perform the job and are slaves in the MapReduce jobs. Actual execution of tasks is done by task trackers, which reside on every data node of the cluster. Task trackers start map jobs. They periodically send a heartbeat message to the job tracker. Heartbeat message have two functions. It informs job tracker that task tracker is alive and are also used as a communication channel. Now, we look at an example of MapReduce. We are going to do word count of words in a file. Here, the input file is split into 4 blocks, which will be processed by each mapper. Mapper generates keys as words and values as 1. That means, even if one word occurs twice, it will be put as separate key-value pairs. Shuffle stage will sort the unique keys together. Each key will be given to a reducer and the count of occurrence of each word will be calculated. The output will be stored in the HDFS. Algorithms that can be parallelized can be executed using MapReduce to reduce execution time. So, we can summarize that we can use the divide and conquer strategy of MapReduce for solving computationally intensive tasks.